Take 71. All right. Caffeine. Do a combustion reaction, okay? It contains C, H, N, and O. That's the important thing to know. Pay attention to what it has, okay? This is the amount of sample we use. We get this much CO2, we get this much water, this much nitrogen. All right. For all these problems, CO2 goes to C, H2O goes to H, and for this kind of thing, so I think obviously N2 goes to N. So, for all of those, we have to first, how do we get O? Okay. Well, we know how much sample we have. So what we're going to do is we're going to take all these to their elements, to the grams of their elements, and then subtract from this one to get grams of O. Okay? So let's go for the ride and see what happens. 0.682 grams of CO2. There's 44.01 grams of CO2 in a mole of CO2. 1 mole of CO2, 1 mole of C, and in 1 mole of C, there's 12.01 grams of C. So how many grams of C do we have? 0.1861. Okay, so that's how many grams of C we got. So now we do the same thing with water. We got 0.174 grams of water. There's 18.02 grams of water in a mole of water. And then the trick, 1 mole of water, there's 2 moles of H. That's a whole H2O, right? So there's 2 moles of H. And then for every 1 mole of H, there's 1.008 grams of H. So we have 0.01947 grams of H. 0.110 grams of N2 times 28.02 grams of N2 in a mole of N2. Same thing as water. 1 mole of N2, 2 moles of N, and 1 mole of N, 14.01 grams of N. Oddly enough, this always baffles me, but I do the calculation every time. It's 0.110 grams of N. Let's not go there. Let's not try to figure out why. Just, it is. Okay? I think it makes sense, but it's odd. I'm not going to lie. So now, looking at our sample, we have 0.376 grams of sample minus 0.1861 grams of C minus 0.01947 grams of H minus 0.11 grams of N. Okay? And so that 0.06043 grams of O. These are our numbers that we're going to use now to do this problem. Okay? So we have 0.1861 grams of C. Let's start using green. 12.01 grams of C, 1 mole of C. Remember, 0.0155 moles C, I think. We just have to get this to be a mole ratio. 0.01947 grams of H times 1.008 grams of H, 1 mole of H equals 0.0193 mole of H. 0.110 grams of N times 14.01 grams of N, 1 mole of N equals 0.00285, I think. I think I'm a little light on digits here. I think it would be a little bit better if we had a few more. 0.06043 grams of O, 16 grams of O, 1 mole of O, 0.00378 moles of O. Okay, so, oh, I'm sorry, I messed up. 00785. My writing is so horrible, but I read it wrong. I'm sorry. That's a 7, not a 2. Okay, so our smallest number is this one. So we divide everything by our smallest. Okay, so when you do that, you should get C4H5N2O. The important thing to remember, CO2 gives C, H2O gives H. Neither of them give O. O you have to figure out by subtracting or doing something clever. And then nitrogen obviously gives nitrogen. So one more problem exactly like that. Let's do this one. I'll do this one a little bit quicker. Okay? Same way. 3.93 grams of CO2. Again, CHNO. We're going to get CO2, we get water. This one uses a separate experiment to make nitrogen, to make ammonia. And so ammonia is going to give us nitrogen. And so we're going to do this one by percentages. So 3.93 grams of CO2 times 44.01 grams of CO2, 1 mole of CO2. And you could have done the last one by percentages too. 1 mole of CO2, 1 mole C. 1 mole C, 12.01 grams C equals 1.0725 grams C. Okay, now we have 2.175 grams of sample for that experiment. 75 grams sample equals 49.31% C. So you do the same, 1.87 grams of water, okay, 18.02 grams of water, 1 mole of water, and then 1 mole of water, 2 moles of H, 1 mole of H, 1.008 grams of H. So 0.20921 grams of H. Again, we're going to divide by that 2.175 grams of sample, and then times 100 always to make it a percentage, okay? So I just kind of left that off, I'm sorry. So that's 9.62% H. Okay. Notice for both of those things, we use this mass right here. Okay. I say that because now we're going to do the nitrogen one. And for that one, we have 0.436 grams of NH3 times 17.034 grams of NH3, 1 mole of NH3 for every mole of NH3, there's 1 mole of N. And for every mole of N, there's 14.0, is it 1? 1 grams of N. So 0.35860. Okay. But notice, so it's a different experiment. So now we have to divide by this number. So divided by 1.873 grams a sample. It was a different experiment. Don't worry about why or anything about that. So it's 19.15% N. Okay, so now percent O equals 100% minus 49.31% C minus 9.62% H minus 19.15% N equals 21.92% O. Now you do it like a normal problem, okay? So 49.31 grams of C, I'm going to take it out, and it's going to be 4.1057 moles of C. And you do that for all of them, okay? So you do that for C, 9.62 grams of H times, 1.08 grams of H, 1 mole of H, equals 9.5437 moles of H. 19.15 grams of N times 14.01 grams of N, 1 mole of N equals 1.3669 moles of N, and then 21.92 grams of O times 16 grams of O, 1 mole of O, equals 1.37 moles of O. So divide by 1.37. This Apple Pencil has a hard time with dots. So 1173. So our formula is C3H7NO. There we are, done with that one.